We have been talking about writing the equations in different forms, and the last 2 days we've been concentrating on intercept form. Today we're going to start looking at vertex form. And a reminder of what your vertex form is from the other day: y equals a times x minus h quantity squared plus k. And because it's vertex form, remember the information that we can see from the actual equation is the vertex. So we look at the graph, and we did this with intercept form. We look at the information that we need. For intercept form, we needed the two x-intercepts. For vertex form, we need that vertex. If I look, the vertex is right here at 5, -4. So the first thing I'm going to do is I'm going to go back and I'm going to plug in that vertex. So we've got y equals a times x minus, this is your h and this is your k. So I'm going to be subtracting 5 quantity squared minus 4. Remember, anything that you have on the inside of the parentheses is the opposite of what you see on the outside. So just like with intercept form, after I get that critical piece of information, the only thing that I have left to solve for is that a value. To solve for the a value, what I need is to find any random point on the graph, and we see that we have a point indicated for us to use at 2, 4. We plug that information in, so this is the x value, this is the y value. So we've got the y is 4, we still don't know the a, that's what we're looking for. The x is 2, quantity squared minus 4, and we've got 4 equals a times 2 minus 5 is a -3, quantity squared minus 4. At this point, it's going to be an order of operations, so we want to evaluate the exponents first. And -3 squared is going to give us a positive 9, so that's 9 times a minus 4. We add the 4 over. 8 equals 9a. We divide by 9. And we find that that missing a value is going to be 8 over 9. This is what we needed to complete that equation. So in the end, our equation in vertex form ends up being y equals 8 over 9, parentheses x minus 5, quantity squared, minus 4. So that again is when you have a graph, when you have information given to you. To write the equation in vertex form, you need a vertex and any point on the parabola. So let's go ahead and look at another aspect of vertex form, how to write the equation from standard form to vertex form. For intercept form, all we had to do was factor. Not going to be the case for writing in vertex form. So there's a couple of things that I want to review that's going to be helpful when writing our equation. First, reviewing how to FOIL. We have this quantity x plus 3 squared. That means we've got x plus 3 times x plus 3. It's that quantity 2 times. We distribute x times x is x squared plus 3x plus 3x plus 9, which gives us x squared plus 6x plus 9. X minus 2 quantity squared, again, that means that I have that quantity multiplied 2 times. So that's x squared minus 2x minus 2x plus 4. We have two of the middle terms being exactly the same. And that's because we have the same quantity, so minus 4x plus 4. Then factoring is undoing that FOILing process. Remember, we're looking for two numbers that are going to multiply the outside and add to the middle. So we've got x plus 4 times x plus 4, which we talked about the other day, that we want to make sure that we simplify down into x plus 4 quantity squared. Multiply the outside, add to the middle. This time I'm multiplying to a positive, adding to a negative, which is going to make each of my pieces negative, but they're the same piece, so it's x minus 9 quantity squared. What we're going to do to help us write our equation from standard form to vertex form is completing the square. Completing the square is finishing a perfect square trinomial. So our goal is to make a trinomial, and this is a trinomial. Trinomial has 3 pieces. We want to complete the square so that it's a perfect square trinomial. That means that when I factor it, I get the same quantity 2 times. So as we look down at the bottom of this paper, find the value of c, so I'm looking for this value of c that's going to make it a perfect square trinomial. So I want to know what value of c that when I break it apart, it's going to be the exact same number twice. I want it to be the exact same number twice so that I can write it as a squared binomial. So I'm thinking about what number am I going to add so that I get 16 and 16? Or that when I add together, I get 16. So the number that I know I'm going to add together to get 16 is 8 and 8, which means that my c value has to be 64. And again, that would be x plus 8 quantity squared. But what we're looking for here is that c value. That's the value I'm looking for to complete that perfect square. Likewise here, I'm looking for what number, when I factor, is going to complete that trinomial so that when I factor it, I get the same number twice. Well, the number that I have to add twice here would be -2 and -2. Well, -2 quantity squared is a +4. So that's that c value that I'm missing, because -2 times -2 is going to give me a +4. Those examples aren't too bad, but sometimes they get a little more difficult. So maybe you read it, maybe you didn't. But the key here is to take half of the middle term and square it. So when I get into harder problems like this right here, I'm going to take half of that 5, which is 5/2, and we square it. When you square a fraction, it is 5 squared and 2 squared. So that gives us 25/4. Now what that really means is that when I go to factor this, it becomes x plus 5/2 times x plus 5/2. If you notice when you factored each of these times, this number was half of the 16. This number was half of -4. So that when I go to factor this is going to be half of that given value of 5. All right, one more example. We take half of the middle term. This is a -1. Remember, if there's no number, it's a 1. -1/2 squared is going to give us a +1/4. So this gives me x squared minus x plus 1/4. When I factor this, it looks really crazy, but remember, this number is always going to be the number that it breaks down to. So it's going to be x minus 1/2 times x minus 1/2, which is really x minus 1/2 quantity squared. So now why are we reviewing all of this? This is how we're going to go from standard form to vertex form. So we turn over to the back side. So when we go to write something in vertex form, we're going to complete that perfect square trinomial. But if you look at your setup right here, you already have that third term, that c value. The thing is that c value is not the right c value. It's not making a perfect square trinomial. So we're going to concentrate just on the x squared and the 12x. We're going to take these two pieces and make a perfect square trinomial. So the first step, and one of the most crucial steps, is to set up your equation. Set up our work. So I've got x squared plus 12x, and my job is to find that c value that's going to make that true. So again, we're just looking at this down here, and we're completing the perfect square trinomial. To do that, we take half the middle term, which is 6, and we square it. And 6 squared is 36. Now we know in order to keep our equation in balance, whatever we do to one side, we have to do to the other side. So over here, since I added 36 here, I'm going to add 36 over here as well. That's how I'm going to keep my equation in balance. So now I have y plus 36 is equal to my perfect square trinomial. Remember, we did this. The whole point of creating that perfect square trinomial is so that when I factor it, two numbers that multiply to the outside and add to the middle is going to be the same number, and that is x plus 6 and x plus 6. When we have that perfect square trinomial that gives us the same two factors, we write it as x plus 6 quantity squared plus 12. Now we're almost in vertex form. The only thing we have left to do is to isolate our y value. So we move our 36 over. We get y equals x plus 6 quantity squared. 12 minus 36 is going to be a negative 24. From this equation, we can identify the vertex. The x stays with the x, so I see a positive 6. That means my vertex is at a negative 6, negative 24. Anything inside of the parentheses is the opposite of what we think. All right, so let's try that again. Again, when we are going from standard form to vertex form, we are going to be completing the square. To complete the square, we concentrate just on the x squared and the x. We're going to use those two terms to make that perfect square trinomial. When I set it up, I know whatever I do to one side, I have to do to the other. We're going to use these two pieces to make that perfect square trinomial, and that minus 3 is just hanging out outside. So far in this first step, I haven't actually made any calculations, done any math. I've just rearranged my pieces so that it's set up to complete the square. To complete this square, I take half of my middle term, so half of 10 is 5, and then I square it. 5 squared is 25. Now if I add 25 to the right, I have to add 25 to the left. So this becomes y plus 25. And this whole piece, looking for two numbers that multiply to the outside and add to the middle. If I were to factor that, that would be x plus 5 and x plus 5. Again, we did that on purpose. The whole point of doing this to get that perfect square trinomial is so that I could write it as a binomial squared. We need that binomial squared for vertex form. So we have that vertex form. Reminder is y equals a times x minus h quantity squared plus k. So we need that piece squared for our vertex form. The last step is to move that 25 over, and we get y equals x plus 5 quantity squared minus 28. And now that we have our equation in vertex form, we can see our vertex, the opposite of what we see inside, which is a negative 5. Whoops. And exactly what we see on the outside, so it's a negative 5, negative 28. All right, why don't you go ahead and press pause now and try number 3 on your own. All right, go ahead and check to see how you did. If you need to pause and go back and make corrections, go ahead and do that. Let's move on to number 4. For number 4, like always, we set up our equation, y plus some number that's going to keep our equation in balance. We're going to complete the square always with the x squared and the x given to us. We ignore that negative 1 out there for right now. We just take those two terms. This time is the first time that we have such a not so nice number. So I take half of that middle term, which is 3 halves. I square it. 3 squared is 9. 2 squared is 4. So I'm going to add 9/4 to both sides to keep my equation in balance. When I go here, we've got y plus 9/4. When I go to factor this, before we could go ahead and factor it into our two trinomials and then into our two factors and then write it as a binomial squared. Know that when things get more complicated like this, our binomial squared is always going to be that half of that middle term. So this is really x plus 3 halves quantity squared. Just like over number 3, half of the middle term, half of negative 2 is negative 1. That is what our binomial squared is going to be. And 1 half of the middle was 6. That's what it ended up factoring to be. Half of 10 was 5. That's what our binomial squared was going to be. So I don't even have to go through that whole process. I just know it's going to be half of that middle term. Do pay attention to whether it's positive or negative though. Last step is to move the 9/4 over. So we get y is equal to x plus 3 halves quantity squared. A negative 1 minus 9/4 is going to be a negative 13/4. Make sure that you are able to make those calculations in your calculator if you can't do them on your own. So don't forget, it's the opposite of what you see on the inside. So since I see a positive 3/2, it's really a negative 3/2. Exactly what you see on the outside at that negative 13/4. Okay, so now that we've got the whole completing the square process down, we're going to complicate things a little bit. When we get into 5 and 6, just like factoring, when our leading coefficient isn't a positive 1, it's going to make things more difficult. We're still going to start the exact same way. So y plus some unknown number, and we're still going to use those two terms to complete our square. So we've got 4x squared plus 40x plus some number plus 280. But now when I go to factor this, I see that after I've grouped these two, that 4 and 40 share a factor of 4. I'm going to pull out that GCF of a 4. So that becomes x squared plus 10x plus some number. Notice that I did not take the 4 out of 280. The 4 is only going to the parentheses, which is only going to the x squared and the 10x. So it only came from the 4 and the 40. We don't pull the 4 out of the 280. The 280 just hangs out there. So we take half of our middle term, which is 5. We square 5, which we know is going to be 25. And then we add 25 to the left-hand side. The only problem is we're trying to keep our equation in balance. I didn't just add 25 to the right-hand side. I have 4 of those trinomials. So instead of adding 25, I really added 100. I added 4 of those 25s. So this time, to keep our equation in balance, it's a little bit trickier. Whatever number I pulled out, that's how many trinomials I have. That's what I have to multiply that c value by. So now we've got y plus 100 is equal to 4 times, factoring still goes the same way. Two numbers that multiply the outside, add to the middle, 5 and 5. Again, that's half of that middle term. So it's x plus 5 quantity squared plus 280. As always, our last step is to move that 100 over. So y equals 4 times x plus 5 quantity squared plus 180. There's our equation in vertex form. The vertex is going to be at -5, positive 180. Opposite of the inside, exactly what you see on the outside. Last one. Just like before, we see that we have a number with our x squared. We start our setup the exact same way, so it's y plus some number equals, we're always completing the square with just the x squared and the x term. That -27 is just going to hang outside. Now I can't complete the square until I have that be a positive 1. So I need to pull out that -3. When I pull out the negative, this makes this positive, and when I pull the -3 from there, that makes it a -8x. So don't forget and make sure that you're pulling the negative from both pieces. When you are completing the square, the only way to do this step of completing the square is if that is a 1x squared. So we have to pull out whatever coefficient that is, which in this case is a -3. Then we go on, take half of the middle, which is a -4, quantity squared, which is 16. Remember, I'm not just adding 16, I'm adding -3 16s. So that gives us y minus 48 is equal to a -3, half that middle term. My binomial squared is x minus 4, quantity squared, minus 27. We move our 48 over. We end up with y equals a -3, x minus 4, quantity squared. -27 and positive 48 gives us a positive 21. There's my equation in vertex form. The vertex is the opposite of what you see on the inside, exactly what you see on the outside. All right, and that is it for our video on vertex form. Given the information from the graph, plug in your vertex, plug in a point, and solve. For writing from standard to vertex form, you've got to go ahead and complete the square.